So, good afternoon, friends. In the last lecture, we have learned how the Boltzmann distribution affect the equilibrium constant value as well as the quotient value, Q value. Today, we will see about the response of equilibria to the conditions, the response of equilibria to the different conditions. What are those conditions? We will see in detail in the today's lecture. As I have told you that the suppose the A plus B that gives C plus D, we are learning the equilibrium constant values. So if this reaction is proceeding and the reaction is proceeded and it has taken sufficient time and the equilibrium is attained, in that case we can calculate the equilibrium constant value K, right. Now at time t for sufficient time the equilibrium is reached. We said that the equilibrium is reached. In this case, that equilibrium constant value or K value or this equilibrium reaction can be disturbed by different number of ways. Number one, by changing the concentration of the reactant as well as product, changing the concentration of the reactant as well as the product, or by changing the pressure. Changing the pressure means changing the value, change in the pressure of this reaction, and or volume, pressure or volume. If you change the pressure, automatically volume changes, or if you change the volume, automatically pressure changes. Number third is the temperature. So if the reaction is at the equilibrium position, this reaction is at the equilibrium position, it has taken the sufficient time to reach the equilibrium position, and the reaction is not at the forward direction and is not the backward direction. In that case, delta G is equal to 0, means further reaction is not proceeding. So this reaction can be disturbed, that can be affected at that time when the equilibrium attained by changing the concentration of the reactant as well as the product, or changing the pressure, which means that obviously changing the volume, and other way of disturbing this reaction is changing the temperature. So if the reaction this reaction changes, if I change this different parameters of this reaction which is already at the equilibrium position, then the reaction will shift to that direction which gives the less stress. Less stress means what? If we change the concentration of the reactant, the reaction which is at the equilibrium, already at the equilibrium position C plus D, equilibrium position, and equilibrium constant can be calculated at the time of equilibrium is reached. And if we disturb this equilibrium constant value or this equilibrium reaction, then what we will do? Either we can change the concentration of the reactant as well as either we can change the concentration of the product, right? Then depending upon the which have this reaction to overall reaction have the less stress to attain the less stress value, that side the reaction will be shifted. Means if the reaction proceeding to the forward direction and the stress is removing or the stress is becoming less, then the reaction will move to the forward direction. If the overall reaction stress is less, to move if the reaction is moved to the backward direction, the reaction will move to the backward direction. So that is called as the Le-Chatliers principle. Le-Chatliers principle. What is the Le-Chatliers principle? The reaction is shifted to the less stress side, means overall stress of the reaction becomes less. Either it can move to the backward direction, either it can move to the forward direction, but overall the reaction stress becomes less. That is called as the Le-Chatliers principle, right? Then Let's see one by one how the equilibrium constant value or constant factor value K affect the change in the concentration, or how it response of the equilibria to concentration, right. Now let's consider our favorite reaction, that is N2 ammonia, formation of ammonia, that is N2 gas molecule, N2 nitrogen gas molecule, right. Just a moment. Nitrogen in the gaseous state plus hydrogen 3s2 in the gaseous state, which gives the ammonia. Again, this is the reaction in forward as well as backward reaction. 2 moles of NH3 molecules are formed. Right. Now, this is the chemically balanced reaction. Right. Then, according to the above reaction or this reaction, the equilibrium will favor to the reaction that uses of that the substance is added according to the Le-Chatliers principle. What Le-Chatliers principle is said that once the reactant system has reached the equilibrium, it remains at the equilibrium until it is disturbed by the some change of the condition like temperature, pressure, concentration. The principle of this system at the equilibrium disturbed by changing its condition, applying the stress, the system shifts in the direction that reduces the stress. If the sufficient time is given, new state of equilibrium is established, that is called as the Le-Chatliers principle, right. Then let's try this Le-Chatliers principle for this reaction, that is synthesis of ammonia. Number 1, according to reactant, the above reaction at equilibrium will favor that the reaction uses up to that added substance according to the Le-Chatliers principle. Hence, the forward reaction is favored, which results in the more formation of the ammonia. This can be very well explained by the calculating the Q value, right. If you change the concentration, if you add the hydrogen in this case, if you add the reactant molecule as the hydrogen, then what will happen? Obviously, concentration of hydrogen as well as nitrogen increases, which results in the formation of the forward reaction. That can be explained by the Le-Chatliers principle by calculating the Q value. Then Q is equal to, we have calculated, we know that is the NH3 concentration product divided by reactant. It is the product of product divided by reactant, arranged their proper powers, right. NH3 square, this is there are 2 number of ammonia molecule, that is concentration of N2 divided by concentration of H2 raised to how much? There is 3 number of moles of hydrogen, therefore that comes out to be hydrogen cube. At equilibrium, we know that what? At equilibrium, Q is equal to K. When the equilibrium is, we know that at the time of equilibrium, Q is equal to K. When the more H2 is added, denominator decreases and Q value decreases. More H2 is added, hydrogen is added, right. If the hydrogen is added, then what will happen? Denominator increases, Q value decreases. This denominator increases. If hydrogen is added, this Q value therefore decreases. Overall value of Q decreases. Why? Since if we increase the concentration of the hydrogen, this hydrogen is the third power, therefore the denominator value increases, therefore the Q value, if the denominator increases, Q value decreases, therefore what? Q is less than K, right. If the Q is less than K, has to re-establish the equilibrium, reaction proceeds to the right direction and the more number of ammonia molecule will be formed. Concentration of hydrogen increases, then automatically reaction to tolerate this stage, the reaction will move to the forward direction. Then more number of ammonia molecule will be formed. Number next, what is happening? B, removing the substance favors the reaction that produces the substance according to the Le-Chatliers principle. Right? Removing what? Removing what? Removing the substance, removing the nitrogen or hydrogen. What will happen if you remove the hydrogen and nitrogen? It favors the reaction that produces the substance according to the Le-Chatliers principle. Means what? This decomposition of NH3 will take place and again reproduce of this hydrogen or nitrogen takes place. Again, at the start, what happened? At the start, Q is equal to K when the equilibrium is reached. As the NH3 is removed, denominator decreases. Right? NH3 ammonia is removed, denominator decreases. Hence, Q is again less than K. To re-establish the equilibrium and the reaction proceeds toward the right hand side. To re-establish again, the reaction will proceed to the right hand side and more NH3 will be formed. Right? So, in this way, the change in concentration of the affect the equilibrium constant value. Right? Next factor. Next factor is what? Response of equilibria to the pressure. Right? Response of equilibria to the pressure. To the pressure. Right? Now, pressure means change in the concentration. Changes in the pressure have the little effect on the concentration of solid or liquid. Since if you consider the solid as a substance, reactant substance, or liquid as a reactant substance, if you apply the pressure on the solid, if you apply the pressure on the liquid, if it is liquid, the volume will not change that much. It will change very little. Therefore, change in the pressure of liquids as well as solid, that will not affect the equilibrium constant value. But in case of the gaseous molecule, it can affect the more changes, because if you increase the pressure on the gas, if the reactant as well as product molecules are the gas, if you increase the pressure, automatically volume may change and automatically concentration of the reactant as well as product may be changed. Now we know that according to what? According to ideal gas equation, PV is equal to nRT. Yesterday we have learned, right? Therefore, pressure is equal to what? N upon V into RT. So, N upon EV is what? N upon V is concentration into RT. Right? Again, if we N upon V, that is moles per liter. Concentration is moles per liter. Right? At constant temperature, what? This N is constant, R is constant, and temperature is also constant. Right? Where? At the constant temperature. I am saying that at constant temperature, the number of moles of the reactant as well as product molecules are constant, and R, that is molar gas constant value, is constant, and as I said, at the constant pressure temperature means the temperature is also constant. Thus, if the volume occupied by the gases decreases, its partial pressure and the concentration increases. Volume occupied by the gases, if we increase the pressure, volume occupied by the gases will be decreases. Therefore, its partial pressure and concentration will be increasing one. Therefore, what will happen to the Q? Q is equal to, we said that concentration of NH3, it is square divided by concentration of N2 into concentration of H2, it is in the cube, right? It is in the third power. If the pressure is increased, then the partial pressure of all species increases. Pressure increase, partial pressure of all species increases. If you increase the pressure, partial pressure of the all species will be increases. Here, the denominator term, concentration of denominator term has the exponent value 3, right? If the partial pressure increases, this value will changes tremendously, because at that same time the ammonia plus hydrogen plus nitrogen, all these gases pressure also increases. Pressure increases, partial pressure increases, right? Then what will happen? Then what will happen? Since this is in the third power, this is in the second power, it is in the exponent, right? Therefore, what will happen? Q is again less than K. Q will be again less than K. Since why? Because this term is in the third power, concentration increases, it is in the third power, therefore automatically denominator value increases, therefore Q value also decreases. Hence, to re-establish this equilibrium, what will do the system? System will result, number one, what will do the system? System will result if there is no change in the total number of gas molecules in the balanced chemical reaction, then pressure, that is volume change does not affect the position of the equilibrium and it remains unchanged. The pressure or volume does not affect the equilibrium constant value if the number of moles of the gaseous molecule are same. Barabar? If the number of moles are constant, it will not affect the equilibrium constant value. Number two, if the balanced chemical change, if the balanced chemical change involves the change in total number of, if this balanced chemical change involves in the total number of moles of gases changing, the pressure is also changing, the reaction mixture changes, the value of Q for the such a reaction, what will do? What will happen? An increase in the pressure. Increase in the pressure in that reaction mixture. If you increase in the pressure, what will happen? Reaction will shift to the direction to the which produces the smaller number of moles of the gases. Reaction will shift where the smaller number of moles of the gases and Q becomes equal to K. Reaction will proceed where if the change in the concentration is taking place, change in the number of moles of the reactant as well as product are taking place. If the balanced chemical change involves change in the total number of moles of the gases, then changing the pressure of the reaction, the mixture changes the value of K. For such a reaction, an increase in the pressure or decrease in the volume shift the reaction in the direction that produces the smaller total number of moles of the gases until Q becomes equal to K. Right. Number next, if the decrease in pressure or increase in volume, if decrease in pressure is decreased, volume is increased, what will happen? Shift the reaction to the direction that produces the large total number of moles of the gases until when? Until Q becomes equal to K. Until when? Q becomes equal to K. Next is what? Response of the equilibrium to the temperature. So what? Response of this equilibrium to the temperature. As we told you that temperature affects the equilibrium constant value. We said that. We already know that. For the exothermic reaction, where the heat is produced, means heat is evolved, if the temperature of such reaction is raised by adding the heat in the system, the reaction will favor the direction that heat is removed. Therefore, which will produce toward the left hand side of this reaction. Right? If it is the exothermic reaction, since the K depends upon the temperature and the changes in the reaction proceeding in the direction that move to the Q value that forms the new value of K. Right? Then, for exothermic reaction, what is happening? For exothermic reaction, delta H0 is equal to positive, as we said that yesterday. The amount of the product that increase by equilibrium, increase in the temperature, at high temperature, the exothermic reaction, delta H0 is negative. Delta H0 is negative for exothermic reaction. Delta H0 is positive for endothermic reaction. Sorry, I have before some time I also told you that for exothermic it is endothermic reaction. Endothermic reaction, delta H0 is positive, and for exothermic reaction we said that exothermic reaction delta H0 is negative. Remember that, right? For exothermic reaction, in this case I told you that exothermic sometime before, but yesterday's lecture I have told you that for the exothermic reaction delta H is negative. Remember that for exothermic reaction delta H is negative, for endothermic reaction delta H is positive. The units of the products are increased, the amounts of the products are increased at equilibrium by decreasing the temperature. The K value is larger at the lower temperature. The value of K is larger. Value of K is larger at lower temperature. Lower temperature, and value of K is smaller at higher temperature. At higher temperature, value of K is smaller at higher temperature. Remember that, right? Then I hope you have understood this video. If you not understood, then watch repeatedly this video. This is very important topic, right? Thank you. Next time we will see the one topic question.